So I will be keep going with the OWASP mobile top 10. So OWASP is one of the most like famous security related, software related foundation in the world, and they are actually like a foundation for the web application security. That's how they started their work. And for in the year of 2025, they are also in the for like mobile application security, large language model security, and AI security, and so on. So if you are talking about an application, if you are talking about an application security, API security related matters, OWASP Foundation is like famous. And they release some mobile risk actually list. So these are like the most common vulnerabilities in the mobile application security area. And in this video, I will be exploring every vulnerability they have actually written, because at the end, what we found when we were doing penetration testing is mostly like hit some of the several of these topics, because like these lists are generated by the community of like the frequency of community of the findings. So that's why when you're doing a penetration testing, you will mostly find the high ranks of the list. So let's start with. So actually there were other lists like 2016, 2014, but we will be talking about the latest list, which is 2024. But I really suggest you to check the other old lists too. So let's start with the mobile one, improper credential usage. So actually, when they release a like a vulnerability, they categorize them like exploitability is easy. So a newbie attacker, a newbie hacker can exploit this. That's what is. And so detectability is easy. So it's easy to detect that vulnerability. So it's like doesn't require any kind of hardcore knowledge, hardcore technical knowledge, and like the impact, business impacts, and so on. So that's how they calculate the risk actually. So this is an area of the like risk and governance. However, as a penetration tester, we need to understand the basics of this kind of matters. So when we check the actually basic examples, am I vulnerable to credential usage? What they're suggesting is if there are hard-coded credentials, it is basically this one. If there are some insecure credential storage or insecure credential transmission, and if there's a weak user authentication, that is also like improper credential. So they actually gives you like some, if you are a developer, they give you some tips like encrypt, like you should encrypt credentials during transition, you should do some regular update and rotate for API keys, and so on. And there are also some example attack scenarios. So I think this section is the important one, because when we're doing a penetration testing, we can like have some similar cases like their scenarios. So like reading them, understanding them could benefit us when we're trying to find some findings. So let's try to read and understand. Hard-coded credentials. An attacker discovers hard-coded credentials with the mobile application source code. They use the credentials to gain unauthorized access to the sensitive functionality within the app or backend system. So let's just imagine that there is an admin panel and their credentials are hard-coded, stored in the APK file. Like the developer couldn't think that the APK file will be reversed and the hacker gets the hard-coded credential. So they actually led to an unauthorized access. Let's check the second scenario. An attacker intercepts insecure transmitted credentials between the mobile app and backend system. They use to intercept these credentials to impersonate a legitimate user and gain unauthorized access. So this is basically like, let's just think that app communicates with, like, app communicates without without SSL or TLS certificate, and another app can inspect the traffic and stole that app's credentials, so that would be bad business. And if we check this third scenario, an attacker gains physical access to the user's device and extends stored credentials from the mobile app. The attacker uses these credentials to gain unauthorized access. So yeah, I mean, in the world of mobile application, is one of the cases is like when someone gains the physical access to user's device. Actually, so that is why the hard-coded data must be kept encrypted, and so in order to hope that only the person who has the credentials needs to access it, and so on. Go with the second one, inadequate supply chain security. So this is actually mostly related to the third-party apps. So let's just check one scenario. An attacker injects malware into a popular mobile app during the development phase. That the attacker then signs the app with a valid certificate, enters the App Store, bypass the App Store security check, downloads and install the infected apps. The attacker then uses the stolen data to commit fraud and identity theft. So basically, this is like a very common scenario in malware analysis. So I mean, if you are into malware analysis, you can always check our website for malware analysis courses, and we also do some Android malware analysis courses. So if you are into that area, that is one of the expertise area of our team. I really suggest you to check them out. So in the malwares, actually, this is called the piggybacking, one of in the terminology. So most of the attackers put malicious codes into the legitimate apps and redistribute it, so it is very bad, and like, people really believes that kind of stuff, and as a security practitioner, we need to be aware of that situation. If I continue with the authentication authorization problems, so actually, this kind of authentication and authorization problems are really common in the web applications, and it is actually the OWASP for web application number 1. As a scenario in the mobile app, so they first give a hidden service request. Developers assume that only authenticators will be able to generate a service request that the mobile app submits to backend for processing. So this kind of a case you can always find, actually. So this is a very common case. During the processing of the request, the server code does not verify that incoming request is associated with a known user. So it does not check for cookie, it does not check for like a session control, it does not do any of this. Hence, adversary submits service request to the backend service anonymously and execute functionalities. So that is actually one of the common cases in the modern day hacking. So they find some API endpoints and just extract data. So this is like a very common case we see in the world of cybersecurity. Interface reliance. Developers assume that only authenticators users will be able to see the existence of a particular function in the app. Hence, they expect that only legitimate authorized users will be able to issue the request. Backend code that processes the request does not bother to verify the identity associated with the request is entitled to the executed service. So basically, yeah, this is like also very common. So let's just think that there is a login page in the application, and there are some, and when you logged into page, you see some of the like data, and most of the developers think that like they can the login page cannot be bypassed. However, if it is like an exploited activity or something which we will be exploring in this course, like any user can actually trigger to that other data contained page and like get the data. So this is like a very common, and there are also like some either related cases and transmission of LDAP rules. So I'm not reading them all for now. However, I really suggest you to check these 3 scenarios too, cause this kind of an authentication and authorization cases are really common. And by the way, in order to understand these kind of 3 scenarios, you might need some familiarity with the web application security. However, this is not like a must. However, I really suggest you to check the web application security courses. Like, there are some courses on YouTube, there are some courses on like platforms like Udemy and stuff. Also, we also provide web application security courses at Takkın Consultancy. So if you are into that, you can always reach Takkın Consultancy. The like I said, I show you the Takkın Consultancy at the first video we have recorded. So I really suggest you to check or contact if you are into that kind of matters too. So when we check for insufficient input output validation, so this is like, so if you ever like join into the world of cybersecurity, you might actually heard SQL injection, which is like the one of the most famous attack vectors, or like XSS, or like command injection. So these kind of actually input validation based attacks are like the web application attacks. However, since our mobile application will be using a backend API, a backend, they also like, there can be also like SQL injection and etc. So whatever you can find in a web application, you can always find in a mobile application too. You should always remember that. So actually, this is like the one of the cases the vulnerabilities occur because of the input output validation, and they like, you should use output sanitization and some integrity checks in order to prevent these kind of attacks. So let's just check the cases. These are like good scenarios. An attacker identifies a mobile application lacking proper input-output validation and sanitization. By crafting a malicious input containing unexpected characters, they exploit the application. Here, due to insufficient validation, the application mishandles the input. So basically, the attacker executes remote code and gain unauthorized access to the, like, everything. So this is like one of the most crucial, one of the most deadly cases you can ever have. And in the second scenarios, I think this is an XSS. An attacker identifies a mobile application with inadequate output validation and sanitization. They exploit an entry point where user-generated content or untrusted data is processed. By crafting malicious input containing code or scripts, attacker takes advantage of lack of the output validation and so on. So basically, like, these are the common cases. So there was like some XSS during the 2010s, maybe you might have heard in Facebook and stuff. So attacks like cross-site scripting is very deadly for like a big website or like a big application, because if it has like millions of users, the millions of users account can be theft, can be manipulated, and so on, can be sold. So these kinds of attacks, yeah, really scares the people. And for the third one, an attacker identifies a mobile application that processes user provided data and generates a dynamic output. The attacker crafts specially formatted data that exploits the application's output validation. The application fails to properly sanitize it. So it is basically a remote code execution scenario also. Then we check for number 5. Yeah. So insecure communication is like, and they have also like some written for IS specific best practices. So actually this kind of a like the insecure communication thing is mostly related with the mobile phone's other components, so like wireless connectivity, the SMS, the like the cell phone, like the normal cell phone utility, and so on. Also, like if it has like NFC reading, yeah. So like it is basically based on the I/O, the Bluetooth also. So this is basically related with the I/O of the device. And some of the cases would be like mobile app and endpoint successfully connects and perform a TLS handshake to establish a secure channel. However, the mobile app fails to inspect certificate and accepts any certificate offered by its server. So any like a modified application, modified server could exploit this vulnerability. So on. So like there can be cases that two-factor authentication could be bypassed because of the lack of like non-secure channel communication. And like for the other cases, I suggest you to check them out. Because of the limited time, because we are on a schedule, I am just passing through. So this is related with the privacy controls, other topic. So the privacy controls are mostly related with the credit card data, like the specific data, name, gender, age, and etc. So these are like private data, and this needs to only be like accessed by you because you consent them. So if you are like into these kind of areas, I suggest you to check like some of the information security related courses and resources. So we will only be checking the first scenario, inadequate sanitization of logs and error messages. Reporting of logs and exception is essential for quality assurance of a productive app. That's true. Crash reports and other usage data helps developers to fix bugs and learn about how their app is used. However, logs and error message must contain PII if the developers choose to include this data. Yeah. So let's just think that when your application crashes, when your application does some unintended actions, they just print your personal data. So that would be really bad, and this is like a finding for us. So everything I am telling you is basically a finding for us, so we can always write into the penetration testing report, we can always report them into the bug bounty to get our money. So this is actually like a juicy areas for us. And insufficient binary protection, yeah. So basically, yeah, like the APK files, I will be giving you much more details in the following lectures. However, the APK files also contain binary files. So these binary files can be reverse engineered, and we will, which definitely going to do some reverse engineering with Ghidra at Kali Linux. And those reversed binaries could sometimes give us some clues about the application, can sometimes contain some like hard-coded API keys. So the difference between the other finding in this list, these keys, if you find these keys in a binary file by reversing the binary, this is where you are right now. And sometimes like by reversing these kind of binary files, you can bypass some license check. So this is basically, maybe you might have heard they call them cracking the software and so on. So sometimes the applications can be cracked with this kind of license check in the binary file. So if you can like bypass that kind of binary check, you can crack the app. So this is a finding for us to report, and if it's a bug bounty, they will definitely pay you if it is in the scope, of course. And we will be talking about what is bug bounty, how can we make fun from that in lesson 12. So the other one is security misconfiguration, and check. So this is actually like one of the basic stuff when you first build the application. So you try to find some default credentials, you try to find some insecure permissions, and like you try to understand is the app in the debug mode or something or so on. So one of the cases would be a mobile app is released with the default settings that have weak security configuration enabled. This includes using insecure communication protocols, leaving default usernames and password unchanged, and not disabling debugging features in release builds. So basically this one is a developer version, and we have the developer version. It's not ready for the production. Attackers exploit this misconfiguration to gain unauthorized access to sensitive data and perform malicious actions. Also, attackers can like inject some malwares and try to like distribute this kind of a APK too. And other when we check the other scenarios, a mobile app exposes its root path in exported file content provider, allowing other apps to access its resources. So this is like very common. So this is like basically a bug. However, it's a security related bug. A mobile app that stores application shared preferences with world readable permissions, allowing other apps to read them. So this is like a common case in mobile applications. So if it is like, so when you, let's just think that there's an application A, and we trust that application that it is not malicious, and we give them like a camera permission stuff. Like I said, it will be much more detailed. There will be detailed lessons at the Android class, following lessons. So let's just think that we gave application A a lot of permission, and this is like a valid application, and we trust them, and so on. And there's an application B that is very malicious. We don't know where it's malicious, and we don't know what's gonna do. However, we didn't give them like any of the camera access, any of the camera permission or stuff. If the application A has some like this kind of vulnerability, that application B can access camera via application A. So for an user, you didn't check the button for allowing the application B. However, they can access to device's camera via application A. And this is also like similar for the exported activities. A mobile app exports some activity that is meant for internal use, giving attackers extra attack surface for application. And also, yeah, this is like the scenario 5. A mobile app has excessive permissions that are not essential for its core functionality. For instance, a simple flashlight app requesting access to user's contract, location, and camera. This exposes user data to an unnecessary risk, as the app could potentially misuse the granted permissions or intentionally leak. Yeah, this could be an intentional leak or unintentional leak. So this is like actually the difference between vulnerability and malicious activity. And we, like I said, if you are into those kind of areas, you should check out the Takkun courses. 2 more to go. Then for the 9th, let me check. So this is insecure data storage, and it is about the data storage mechanism. So like there are some secure storage mechanism that the operating system offers you, like they also provide single sign-on mechanisms, and for now they are also using like some biometric information and stuff, and these are like good practices for an application to use. However, not all of the applications implement that kind of mechanisms that may cause some vulnerabilities. And this kind of vulnerabilities attack scenarios could be like mobile application stores user password in a plain text format within a local database or file, So this makes it easy for an attacker to retrieve and abuse credential when they have gained unauthorized access to device. So this kind of an unauthorized access not all the time could be physical. So if they download some malware, some malicious app, that malicious app could also cause that kind of a problem. So logging also must be like implemented with the proper security controls and also caching. So for another case, the application stores sensitive user data such as personal identifiable information locally on the device without utilizing proper access control or encryption. This allows anyone with the physical access to device extract and view the data. So this can be a case. The mobile application utilizes cloud storage services to store user data but misconfigures the storage permissions, allowing unauthorized access to the stored information. This can result in data leakage or unauthorized exposure of data, yeah. And for the last one, insufficient cryptography. So if you are not like cryptography is like one of the key concepts of cybersecurity, and if you are like a really newbie for that, although I will be like talking about cryptography at some points of this course, however it won't be like a cryptography focused course. And if you are not familiar with that kind of terminology and like terminology and basics foundations, I suggest you to get an introduction to cybersecurity course or like get an introduction to network security course. That will be like the essential things for this kind of basic stuff like Linux essentials, network essentials, programming essentials, and like the cryptography. So these are like I think the four horsemen of cybersecurity that you need to follow. So basically, cryptography provides that the critical information kept as in another format. So this is like a basically an area of science and mathematic, and like in the application security, based on the framework you build it, based on the operating system you build it, based on the programming language you use it. There are some like best standards, like the best practice function and encryption standards that you follow. And most of these attacks, like the insufficient cryptography, based on like the misusage of that best practice. So what can be, yeah, let's check the examples. Sorry, not this one. So actually, I'm sorry. So like we should use some strong encryption algorithms, and the key length must be strong. So like there are some widely accepted and secure encryption algorithms that we accept as a worldwide citizen, and we need to stay updated with the current cryptographic standard, and we shouldn't use like weak algorithms, or we shouldn't use some algorithms that we have implemented by ourselves, because in like I said, in cryptography there are some standards we need to follow. And the k length, like I said, must be like follow the standards. And for the k management, the practices must be followed like also, and encryption keys must be stored very securely, and also validation and authentication must be applied, and so on and so on. And for hashing, yeah, the strong hash functions like the resistant hashing functions must be implemented. And also, if we are like storing a very critical information, we should always use salting. So salting means that, let's just say we encrypt A, we don't just only encrypt A, we add something like AB, make it AB, then encrypt it. That makes like adds an extra layer of security by making it harder for attackers to use pre-computed tables or remove tables to crack passwords and so on. And as the last, when we check the example attack scenarios, we see that the man-in-the-middle attacks are always like one of the most common vectors. So an attacker intercepts the communication between the mobile application and the server. So basically, this needs to, like, attacker needs to be the network somehow, but it's possible. Weak cryptography can enable attackers to decrypt the intercepted data, modify it, and re-encrypt it for forwarding it to the intended recipient. Like I said, if you are not familiar with this kind of attacks, I really suggest you to check Introduction to Cybersecurity and Introduction to Network Security courses. This can lead to unauthorized access, data manipulation, or the injection of malicious code. So the scenario 2 would be a brute force attack. Attackers systematically try various combinations of this until they find it. And weak cryptography can shorten the time for that kind of brute force attacks. Cryptographic downgrade is like one of the most common. Mobile applications may support multiple encryption or algorithms to establish secure connections. If weak cryptography is allowed as a fallback option, attackers can exploit this weakness and force the application to use weak encryption. As a result, they can decrypt the intercept data more easily. So, like the developers do this kind of a fallback mechanism sometimes, and if you are a developer, you should never do that, because like this scenario suggests, this is a very common attack vector that attackers can exploit. And also for the key management, weak key management practices can undermine the security of the cryptographic systems used in the mobile applications. For example, if encryption keys are stored insecurely or easily guessable, attackers can gain unauthorized access to the keys and decrypt the encrypted data. This can result in data breaches. So the key management must be done within the standards, and there are sometimes we see that they are although most of the developers mostly use third-party libraries for encryption, sometimes cryptographic implementation flaws occur. Weak cryptography can also stem from implementation flaws in the mobile application itself. These flaws may include incorrect usage of usage of cryptography libraries, insecure key generation, and improper random key generation. So random number generation, RNG, we called in computer science, is like another world, another stuff. However, this kind the RNG must be random, like a real random, although it can have some seed. So sometimes the vulnerability based on the RNG can also occur. So this is basically under the insufficient cryptography. So to sum up what we have discussed so far, so like I said, OWASP is like a foundation for application security, and we have checked their top 10 mobile risks in the 2024, and this list is, I think, very good. And if you are like not that familiar with the mobile application security concepts, I really suggest you to read all of these links. You just only need to write like mobile top 10 OWASP and search it. So I really suggest you to check all of these sections, and there will be some questions actually in the quiz based on these sections, because I think they give you a good perspective for what is vulnerability, what is malicious act for mobile applications. And if you have that kind of like the basic foundations, it will be much easier for you to search that kind of vulnerabilities and risks. So basically, when we're talking about vulnerabilities, we are talking about the risks of the applications. and they also define the risks, like the threats, the risks, the attack vectors, the attacks, and so on. So that is why I think it's a very good resource. I really suggest you, like I said, to read it, like understand it, then continue with lessons. Sorry, I really suggest you to read it, like understand it, fully understand it, then continue with the lessons. It will be much easier for you. Really, just trust me, just follow the course, then just fine for you.